Hello and welcome. I'm Saeed from StoryPlanet.net. Dive right into the essence of the most captivating books without reading them cover to cover. Whether you're on the go, at the gym, or just relaxing at home, we offer you a unique and enriching listening experience. Today, we are exploring the book, Built, a creation by Roma Agrawal. Published in 2018, Built sheds light on the lesser-known heroes of society, structural engineers. Regrettably, the realm of structural engineering typically garners attention only in situations where something has gone amiss, such as the collapse of buildings or bridges. Agrawal's work, however, goes beyond this narrow focus and provides a comprehensive understanding of the engineering profession. Through a collection of anecdotes and fascinating insights, the book explores the intricate structures that shape our world and introduces us to the individuals responsible for their creation. Before we delve into these revelations, it's interesting to note that Roma Agrawal, a structural engineer based in London, played a crucial role in the construction of the Shard, which is presently the tallest building in Western Europe. Notably, she is widely recognized for promoting interest in engineering, with a particular emphasis on engaging women in the field. With audio and text to unveil, brace yourself for a deep dive into this captivating book. On StoryPlanet.net. To start, explore the benefits of engaging in the field of construction. The text discusses the importance of highlighting the stories behind buildings that withstand natural disasters. It aims to share the stories of engineering ingenuity, calculations, innovative thinking, and problem-solving. The text also mentions that readers will gain an understanding of the history of structural engineering and the scientific skill and artistry behind buildings. Additionally, it hints at interesting facts such as the value of human poop as a resource, accessing water in arid countries, and using animals as a model for buildings. Key idea number 1. An engineer's role is to construct resilient structures capable of withstanding natural forces. On August 27, 1907, a section of the Quebec Bridge collapsed, resulting in the death of 75 workers. This highlights the role of structural engineering in understanding and managing forces exerted on structures. Compression and tension are two key forces that impact structures. Compression occurs when weight is placed on an object, while tension occurs when weight is hung from an object. Ancient civilizations used load-bearing and frame systems to channel these forces. Understanding compression and tension and how to manage them remains crucial in modern construction. Key idea number 2. Modern buildings use the same components as early construction. Engineers often develop an interest in building structures from a young age, often through playing with Lego sets. Modern buildings are similar to Lego constructions, composed of smaller components. These components include columns, beams, braces, and trusses. Columns are upright pillars used for compression, while beams provide horizontal support. Braces and trusses offer stability in larger spaces. Some buildings also have cores, which function as the building's spine and absorb external forces. Alternatively, some buildings use external frames called diagrids or external braced frames. Famous examples include the Gherkin in London and the Centre Pompidou in Paris. Key idea number 3. Structural engineers consider forces of nature like wind and earthquakes in their designs. Wind poses a challenge for engineers, especially when designing skyscrapers. To accurately calculate the wind force, engineers must construct a 2-scale model of the building and test it in a wind tunnel. Some skyscrapers use a tuned mass damper, a large pendulum that cancels out the wind's force by matching the building's resonance frequency. Earthquakes are another concern, and engineers use different methods to counteract them. These include studying past quake frequencies, using rubber pads or dampers to absorb vibrations, and hydraulic shock absorbers. The Torre Mayor in Mexico City withstood a 7.6 magnitude earthquake without any damage. Key idea number 4. Disasters offer valuable lessons for improving building practices. In 1968, an incident occurred in Canning Town, London, where a defective boiler caused an explosion in Ivy Hodges' apartment. This led to the collapse of the high-rise building, resulting in the death of 4 people. The tragedy taught engineers important lessons about structural integrity, such as firmly affixing components and avoiding single points of failure. The collapse of the Twin Towers in 2001 also highlighted engineering flaws, leading to the adoption of stable concrete cores in modern building designs for both stability and escape routes during emergencies. Key idea number 5. Modern structural engineering materials have a lengthy historical background. Bricks have been used for over 11,000 years, with the Romans being masters of brickmaking. The art of brickmaking was lost after the Roman Empire fell. Mortar is essential for holding bricks together, and ancient Egyptians and Chinese developed innovative mortar mixtures. Metal became a viable construction material with the mass production of steel in the 19th century through the Bessemer process. Key idea number 6. Concrete is often perceived as boring, but this is not necessarily the case. Concrete is a crucial construction material that has allowed for the creation of impressive structures throughout history. It is made by mixing limestone and clay, heating it, and grinding it into a powder called cement. When water is added, it forms a strong substance once dry. Concrete has the advantage of being able to resist compression and can be cast as a single piece, making it structurally sound. However, it is weak against tension. In the 1860s, Joseph Monnier developed reinforced concrete by using metal wire to reinforce the concrete and make it stronger. His innovation continues to be used in construction today. Key idea number 7. Modern structures, such as skyscrapers, are designed to be tall and reach great heights. Skyscrapers symbolize human ambition and innovation. The first skyscraper, the Home Insurance Building, was built in 1884. Elevators, made safe by Elisha Otis's invention, allowed for the construction of taller buildings. Today, elevators are used by 7 billion people every 72 hours. Key idea number 8. The ground beneath a structure can determine its fate. Mexico City's historical center has sunk by 10 meters over the last 150 years due to its problematic terrain. The city was originally built on a lake, and when the Spanish conquistadors destroyed the Aztec city and built their own city on top, it caused further problems. The city filled the lake with soil, causing flooding issues. To solve this, underground waterways were constructed. The Metropolitan Cathedral, aware of sinking soil, built a raft foundation but still experienced tilting. A scientist, Dr. Efrain Ovando Shelley, constructed a model and drilled extraction holes to remove soil, correcting the tilt and preventing future sinking. Key idea number 9. Innovative construction techniques can solve water scarcity in arid regions. Civilizations tend to develop around water sources, but engineers have ways of finding water even in arid regions. In ancient Persia, they built a structure called a karis, which taps into underground water sources. Singapore, a small island with a large population, has become a leader in water management. It collects rainwater, reuses wastewater, and has a desalination plant. These innovations provide 50% of Singapore's water, with plans to increase to 85% by 2060. Key idea number 10. Human excrement has played a significant role in the development of civilization. The text discusses how the way a culture handles human waste can indicate its level of advancement. In Japan, farmers used human feces as fertilizer, leading to a booming market for it. Laws were passed making landlords the owners of their tenants' feces. However, the system faced problems in the 20th century due to population growth and inadequate sewage systems. London also faced similar challenges, with human waste being thrown into rivers causing outbreaks of cholera. In response, a sewer system was developed in the mid-1800s. Joseph Bazalgette designed a network of tunnels to carry waste out to sea, and the system was completed in 1875, greatly improving the lives of people in London. Key idea number 11. Some women have been pioneers in addressing gender inequality in engineering. It can be challenging for women in male-dominated industries, such as construction. However, aspiring female engineers can find inspiration from figures like Emily Warren Roebling. Despite not receiving formal training, Emily played a crucial role in completing the construction of the Brooklyn Bridge, alongside her husband, Washington Roebling. After Washington fell ill, Emily took on his responsibilities and successfully managed the project, eventually standing beside President Chester A. Arthur when the bridge was opened in 1883. Key idea number 12. Structural engineering has a promising future. The future of engineering looks promising with the emergence of new technologies. Cheaper and more efficient construction techniques are being developed, such as using plastic molds instead of expensive plywood ones. 3D printing allows for lower-cost production of component parts and the use of recycled materials. Robots are assisting in various construction processes, including analyzing structural integrity. Biomimicry is being used to model buildings after natural structures, resulting in strong and lightweight designs. Innovation is key, and the possibilities for future engineering structures are limited only by our imaginations and ambitions. In conclusion, modern architecture is the result of centuries of building knowledge. Understanding this history helps us appreciate the structures we see. Engineers play a crucial role in assessing forces and ground conditions for construction. With advancing technology, the field of engineering is becoming even more exciting. Thank you for listening to this summary. If you enjoyed this exploration, we invite you to discover other fascinating books on storyplanet.net. Don't wait any longer. A multitude of books, stories, and knowledge await you there. See you soon on storyplanet.net.